We are going to consider hydrocarbon, presented by Oloruntoba Kayode Segun. This is me. I am your chemistry teacher. I will be taking you through the tutorial class today. So when we talk about organic chemistry, we are simply talking about chemistry of carbon. But the chemistry of carbon we are referring to are carbon in organic compounds, carbon in living things. And that's the first diagram you can see there. I have bonded carbon. That is how carbon bond to each other. You see chemical lab, you see organic carbon. When we say organic carbon, we mean carbon in living things. Carbon in living things, that's what we refer to as organic chemistry. So very fast, we want to consider definitions of terms. What are the terms that we use when we are talking about organic chemistry? Firstly, we want to consider hydrocarbons. And when we say hydrocarbons, what do we mean? Hydrocarbons are families of organic compounds that are composed of carbon and hydrogen only. Take note of that. Hydrocarbons are a family of organic compounds that are composed of only carbon and hydrogen atoms only. Then these hydrocarbons are classified broadly into two. We have the aliphatic compounds. Now these aliphatic compounds, they are grouped into two. In the next slide, I'm going to explain in details the aliphatic compounds. But look at the diagram I just displayed right now. Those are the examples of aliphatic compounds that we have. Then we have aromatic compounds. And this also looks similarly to the aromatic compounds that we have. So generally, hydrocarbons are just classified into two: aliphatic compounds and aromatic compounds. And these two compounds, they have their distinctive properties. They have their different properties and characteristics. So aliphatic compounds now, when we say aliphatic compounds, they can either be acyclic or cyclic. That cyclic is from the word cycle, which means that when we say cyclic, those compounds looks as though you are drawing a circle, any shape. You know, we have triangle, we have rectangle, so they look like that kind of shape. Then acyclic is the opposite. These ones, they do not be the structures don't look like shape. Now this acyclic or cyclic is actually referring to how the shape look like, and that is why we call them we group them under aliphatic compounds. Now what are acyclic compounds now? These acyclic compounds, when you are drawing their structure, they can either be straight chain or branch chain, which means that they have branches. Those branches, by the time we get into the class in full, we call them isomers. Then these acyclic compounds, their family includes alkanes, and alkyne. And this is the diagram of how they look like. You see now, we are talking about structure. So alkane, which is the first one I mentioned, is the first diagram you see. Under it, we have saturated hydrocarbon. So they are still called saturated hydrocarbon, which means that under acyclic, they are still grouped into two. Acyclic compounds are grouped into two, which are called saturated hydrocarbon and unsaturated hydrocarbon. So for saturated hydrocarbon, we only have alkanes. For unsaturated hydrocarbons, we have alkenes and alkynes. For the saturated one, which is alkanes, you will see that in between the carbons, we only have a dash. That dash is called single bond. But when you move down to the next diagram, you will see that in between the carbons is double bond, and that is why we call them alkenes. The third diagram, it is in between the carbon you see triple bond, that is why we call them alkynes. and the one of double bond and triple bond, they are grouped together and they are called unsaturated hydrocarbon. Acyclic compounds. So these acyclic compounds, like I said initially, that they form their shape, their structure look like a cycle, and we have different kind of shape. Let me even put it this way: their compound look like shapes in mathematics. Shapes, we have triangle, we have rectangle, we have polygons. So their shape looks similarly like that of shapes in mathematics. So let's look at this diagram. You can see that the first diagram here looks like triangle, and triangle, as the name implies, tri, which means that three angles or three corners. That is why this one is called cyclopropane. That propane is the number of angles that is there. Then cyclo begins their name because they look like a circle. The next one is, if you count the number of edges that are there, it is 6, and that is why it is called cyclohexane. And look at the other one too. If it is the one of 3 edges will give you cyclopropane because it's 3 edges. The one of 4 edges will give you cyclobutane because it is 4 edges. The one of 5 edges will give you cyclopentane because it is 5 edges. And if it is 6 edges, it's going to be cyclohexane. This is where we are going to stop for today. In the next class, I am going to teach you homologous series and functional group. And we'll be looking at the families, every families that are in homologous series, or every family that we have in organic chemistry or organic compounds. And that is what we'll be considering in the next class. So, see you in the next class.